Good morning, everyone. We're going to talk about section 9.2 here, outcomes, type 1 and type 2 errors. So when we're doing a hypothesis test, remember chapter 9 is all about hypothesis testing. When we're running a hypothesis test, there's actually 4 possible outcomes. 2 of those outcomes are correct outcomes, and 2 of them are actually errors. So we see in this table here we have the top row, true or false. That part we don't actually know in advance because we're doing a test on a sample to try to make a determination about the population, but we don't actually know for certain the condition of the population. So anytime we decide to not reject the null hypothesis, okay, then it's either going to be the correct outcome because the null hypothesis is actually true, or we're going to commit what's called a type 2 error because the null hypothesis is actually false, and yet we have failed to reject it. On the other hand, if we reject the null hypothesis and the null hypothesis is actually true, then we have committed what's called a type 1 error. Or the other possibility is if we reject the null hypothesis and the null hypothesis is actually false, then we have reached the correct conclusion. So each of these 4 things is possible. And what we're going to try to do today in this section is really make sure that we understand what a type 1 error is, what a type 2 error is, and try to kind of just practice wording what type 1 and type 2 errors look like. So here are those possibilities again, just listed out. Again, number 1, if we decide not to reject and the null is true, then that's the correct decision. If we reject the null when the null is true, that's a type 1 error. If we decide not to reject and the null is false, then that's a mistake and it's a type 2 error. And then finally, if we decide to reject and the null is false, then that's the correct decision. And that, by the way, that probability there is tied to what we call the power of the test, which we'll talk about more in just a minute. So each of these errors has a probability, okay? And we note these probabilities with an alpha and a beta. Now we've seen alpha before, and this alpha and that alpha that we talked about in chapter 8, those are connected. Alpha is called the probability of a type 1 error. So it's the probability that we reject the null when we shouldn't have. The null is actually true. Okay, beta on the other hand is the probability of a type 2 error, and that's the probability of not rejecting when we should have. So we would like for alpha and beta to both be as small as we can make them. However, they will rarely be 0 because the only way we could really be sure is if we actually knew information about the population that supposedly we don't know, and that, the fact that we don't know is the reason we're doing a hypothesis test. So here's this power of the test thing again on the last line. The power of the test is 1 minus beta. We would like for the power of the test to be as high as possible, as close to 1 as possible. But again, beta is hardly ever 0, so the power of the test will probably never be exactly 1. All right, so here's some examples. This is the kind of stuff you're going to do in your homework, okay? So we're given a null hypothesis here. Suppose that the null hypothesis is Frank's rock climbing equipment is safe, okay? So the null hypothesis is that Frank's rock climbing equipment is safe. So a type 1 error would be to think that the rock climbing equipment is not safe when in fact it is safe. Okay? A type 2 error would be Frank thinks that his rock climbing gear may be safe when in fact it is not safe. Okay? So in a lot of these circumstances you're going to see that, there's one outcome here that might be worse than the other. So if you're asking that, which error is worse, so it depends on the context, right? In the Frank rock climbing scenario, if Frank assumes his equipment is safe, but it's actually not, that could have bad consequences. That was a type 2 error that time. But think about this example. Suppose the null hypothesis H0 is that a patient is not sick. Okay, the null hypothesis is that the patient is not sick. So a type 1 error would be that the doctor thinks the patient may not be sick when in fact he is sick. Okay, versus a type 2 error, which would be that the doctor thinks the patient may be sick when in fact he is not sick. So as long as we're not talking about amputating something because of a sickness, then a type 1 error is probably worse, right? Again, that's assuming we're not talking about amputation, because if that was the case, then it would be worse for the doctor to think that you are sick than not. But if you actually are sick and the doctor thinks you're not sick, you're not going to get treated, right? So I would say, generally speaking, a type 1 error is worse in this situation because you're sick, but the doctor doesn't think you're sick, and so you're not getting treated. So oftentimes, we kind of have to decide which of these things is the most important. Which, would we rather err on the side of a type 1 error if need be, or a type 2 error if need be? Hopefully, we don't commit many of these errors, but occasionally, it's unavoidable depending on how things stack out with our samples. All right. So this was a short lesson, but your homework is basically just doing what we did there in those couple of examples. Okay, I give you a null, or the book gives you a null hypothesis, and you write out the type 1 and type 2 errors. And then I think some of the questions even ask you, which of these is a bigger deal? Which of these is more important to guard against, the type 1 or the type 2? So hopefully that makes sense. This is this chapter we're taking slow, one section at a time. Hopefully, that works out well, so that everybody stays on track, and we don't have any misunderstandings, or at least as few as possible. So good luck with this. Let me know if you have any questions.